Let me give a quick explanation on Coulomb's law. Let's talk physics today. So Coulomb's law is that law of electricity that states that the force between two charges of a point that is separated with a distance, it says that force is directly proportional to the product of those two charges. Assuming those two charges are called, it says the force is directly proportional to those two charges, assuming the two charges are called Q1, Q2. It says it is proportional to the products of them and inversely proportional to the square of the distance between the two charges. So this is the definition of Coulomb's law in a nutshell. So removing this proportionality sign, we introduce our equals to sign, but we need to put a constant times Q1 Q2 over R squared. So that constant is known to be to the 1 over 4 pi E naught, where E is called permittivity. Yes, and E naught is equals to 8.5 times raised to the power of minus 12 times 10 raised to the power 9 Newton meter square per Coulomb square. So this is the value for our K. It is a constant, so that is the value. Our force therefore is equal to, whenever you want to use this value, maybe you were not given a specific value for this, you will say K is equal to 9 times 10 raised to the power 9 times Q1 Q2 over R square. So this is the formula for the force between two charge bodies separated with a distance called R. So let's go into a question. Let's solve just one question for this video. Okay, here's a question that says three charges plus 10 coulombs minus 20 coulombs and minus 16 coulombs, yes, negative 16 coulombs, are distributed as shown below. Find the resultant force acting on the 10 coulomb charge. You know that in electricity, unlike charges attract themselves and like charges repel themselves. So these charges, the force between them is a force of attraction, and also the force between these two bodies is a force of attraction. Unlike the force between these two bodies, it is a force of repulsion because they are of the same charge, a negative charge. But that is by the side. It says we should find the resultant force acting on the 10 coulomb charge. Let us solve. So our point of concentration is this 10 coulomb charge. So how can we find the force? Let's say force one, we should find the force between these two bodies, these two charges. And let's formula that says 1 over 4 pi E naught times Q1 Q2 over R square. The formula I gave to you earlier. This was the formula I gave to you earlier, where I said the force is equals to K times Q1 Q2 over R square, where K is 1 over 4 pi E naught. So replacing that with this 1 over 4 pi E naught times Q1 Q2 over R square. So using this, we say F1 is equals to, this value is 9.0 times 10 raised to the power of 9 times Q1. Our Q1 will be 10 and our Q2, our second charge, 20. We have to look for this first and look for this. So this is all over the distance separating the two charges, that is 3 meters, and that is squared. So the value of F1 would be what? After using the calculator, it would be 2 times 10 raised to power 11 Newton. So for F2, like we did for F1, we say 9 times 10 raised to the power of 9 times Q1, in this case is 10, Q2 is 16. You don't need to use the negative sign when multiplying. This is over The distance separating them is 2, so that is 2 squared. So our F2 from this is equal to 3.6 times 10 raised to the power of 11 newtons. So how can we find our resultant force? Our resultant force is that force that brings the two forces to equilibrium, that balances the two forces. So in finding that, I should sketch out the diagram for you to understand what I just said. So if this is the two forces according to this diagram, and the force acting towards this direction, which is the F1, is 2 times 10 raised to the power of 11, and the one to this direction is 3.6 times 10 raised to the power of 11 in newtons and in newtons. So the resultant force is that force that comes from this direction. So in essence, in looking for this force, we use the Pythagoras theorem that says the square of the hypotenuse is equals to the sum of the squares of the two adjacent sides, where you know that this is the y-axis, also it is corresponding to this. So this line is equal to 3.6 times 10 raised to the power of 11 newtons. So our arrow from there is equals to the square root of 3.6 times 10 raised to the power of 11 square plus 2 times 10 raised to the power of 11 square. So this is our arrow. So our resultant force then for, let me call it F arrow. I shouldn't call it arrow. F arrow, our resultant force is equal to, after evaluating this value, I got 4.12 times 10 raised to the power of 11 newtons. So this is the resultant force from this question that says 3 charges plus 10 coulombs minus 20 coulombs and 16 coulombs are distributed as shown below. Find the resultant force acting on the 10 coulomb. We use this same method to find the resultant force acting on any of the 3 coulombs, on any of the 3 charges, whether be it the negative 20 coulombs or the negative 16 coulombs. Thank you for watching.